I'm very excited about UCIe as a technology. We have been through 3 generations of the technology evolution, and this is part of a long journey. We see a lot of people making announcements and a lot of interoperability demos using UCIe Express. But at the same time, we are very mindful that these standards are there for many decades. I've been done things like PCI Express. We are been through more than 2 decades of evolution with no signs of slowing down. So UCI started in March of 2022. We're already at 3 generations, and it's the beginning of a journey which will continue on. There are primarily 2 usage models for UCIe. One is, of course, we want to connect chiplets on the package, bring in the innovations that used to happen at the board level onto the package. You put the chiplets together either through planar connectivity or through vertical connectivity. The distance goes down, you get better power efficiency, you get better bandwidth, and overall you deliver a lot of power efficient performance within the package. So that's one thing, which is around the SoC things that were being done is now at a SIP level or system in package level. So system in package now is much more complete with compute, memory, I/O, networking connectivity, maybe optical connectivity, which leads me the second usage, which is package-to-package connectivity at the rack level and potentially at the pod level. Things like co-packaged optics. You can use UCIe, put in your UCIe-based co-packaged optics, take out an optical connection, and then you can connect things on the rack and even across to the pod. Very high bandwidth, very low latency, and very low power. And that's basically how you can deliver the vision of composable systems at the rack level and at the pod level. So imagine that you have a bunch of compute entities, you have a bunch of memory, you have a bunch of storage, you have networking connection, and you can dynamically compose these systems. I need more memory, I can go off through the optical link, co-packaged optics, and get memory from a pool. Or I can have multiple independent servers that are collaborating on a given problem, right? Be it an AI problem, an ML problem, all of those. And that happens with load store interconnects using UCIe on co-packaged optics at the rack level, at the pod level. So that's basically the vision of UCIe, and it's a journey. As I said before, it's an ongoing journey. We'll continue to monitor the demands of the ecosystem, and we are going to continue to evolve the specification to meet those demands. Let me leave you with some thoughts around the key performance metrics that you get with UCIe. So UCIe 2D, you get bandwidth in the range of 200, 300 gigabytes per second per square millimeter. 2.5D, you get bandwidth in the range of 1600 gigabytes per second per square millimeter. And with 3D, you get bandwidth in the range of 4 to 300 terabytes per second per square millimeter. Let's compare that with what you get on external interconnects, whether it is PCI Express or whether it is Ethernet. The amount of bandwidth you get on a per square millimeter basis is in 2 digits. So with UCIe planar, you get 1 to 2 orders of magnitude better bandwidth density. And with UCIe 3D, you get 3 to 4 orders of magnitude better bandwidth density, as you would expect, because these are very simple interconnect. You travel less distance, you can run more wires, you can get more bandwidth, and proportionately your power consumption is also less. The power consumption in the planar case for 2D, 2.5D ranges from 0.25 picojoule per bit to, for longer distance, higher frequency in 2D to 0.75 picojoule per bit. In the case of 3D, the numbers are 0.01 picojoule per bit in 1 micron to 0.05 picojoule per bit in the case of 9 micron. So external interconnects are around 5 picojoule per bit. So you get 2 to 3 orders of magnitude better power efficiency number with UCIe. The other aspect is the power consumption that is proportionate to the bandwidth usage. Because these circuits can be turned on or off very quickly, you can, even planar interconnects, you can turn it on or off in less than a nanoseconds. And you can get 85% power savings With 3D, you can turn them on or off instantaneously. So the power savings is 85%. So you can practically get like a linear curve of power versus actual bandwidth demand. And it's a little harder to get that in external interconnects because it takes multiple microseconds to turn these complex circuits on or off. So that's the other advantage. So you get significantly better bandwidth density, orders of magnitude improvement. You get significantly lower power, orders of magnitude improvement, and you also get power consumption that is proportionate to the bandwidth usage.